Hello. We're going to take a look at the law of sines here. The law of sines is a really useful tool, and one of the things that makes it useful is it can be used to solve any triangle. We've been working with SOHCAHTOA. We've been working with Pythagorean theorem, a squared plus b squared equals c squared. And these are great tools, but they only work on right triangles or 90-degree triangles. Okay, so law of sines can really be used for any triangle. Now, the law of sines, you'll see it written two different ways. Our textbook writes, if we have triangle ABC, then little a over sine of A equals little b over sine of B equals little c over sine of C. And what this means is if I have a triangle ABC, okay, and then across from the angle A is side A, across from angle B is side B, and across from angle C is side C. And this is saying if you take a side divided by the sine of the opposite angle, it is equal to another side divided by the sine of that opposite angle. And so usually we just typically work with these kind of one at a time, like one pair at a time. We typically don't do all three at once. So this is a law of sines. Here's the deal. Here's some different information that you can have for a triangle. You could have a triangle where you have two angles and then the side after them. You could have an angle with a side in between and an angle. You could also have a side, and then an angle. You could have three sides. You could have a side, angle, side. Or you could just be given three angles. Now, something that's interesting here is when this happens, and I'm not going to test you or quiz you on this, but just kind of an FYI, the law of sines works really well on these two, okay? It also kind of works on side angle. I'm not going to hit this too much. This is what's called the ambiguous case. And if you want to learn more about that, you can Google it and look up and learn about it online. These two cases, side, and side, angle, side, we're going to learn that in the next section. That's going to be law of cosines. And something that's interesting with angle is that's not very useful. It just tells us that two triangles are similar. You see these two triangles have the same angles. Even though I'm not telling you what they are, you could see this angle here is the same as this angle here. But the triangles are definitely two different sizes. If I had another triangle that had a side, an angle, and a side, it would definitely be this triangle. Okay. So this is a bit of a side trail. Just know that the law of sines is going to work pretty well. Sometimes it kind of works for side, angle, although I'm going to oversimplify it for this section. But if it doesn't work, then we're going to use law of cosines, which we'll learn in the next section. So let's go ahead and do this. Let's solve a triangle. So I'm going to start. I've got a triangle A, B, C, and I didn't even bother to really draw it to scale. You see that angle A is 80 degrees, angle B is 57 degrees. Oh, that's not right. Angle C is 57 degrees. And side A is 6.58. And now it says to solve the triangle. What that really means is find the other sides and the other angle. And so we need to find angle B, we need to find side C and side B. So to do that, we're going to use a law of sines. A over sine A equals B over sine B, which is also equal to C over sine C. And so as you look, you're going to want to highlight the side and the angle that are pairs, if that makes sense. You'll notice here we have the angle A and side A. This is good because when I set up my law of sines now, I have A and sine A equals, and now I can really go, if I go to sine of B and B, I don't know either of those values at the moment. And so that would give me two variables, and I couldn't solve this proportion. So if I then use C and sine of C, that's going to help me to solve this. So I've got C, the side length, over sine of 57 degrees. All right, so when I solve this, probably most of you are comfortable doing this, but I'm going to do a cross multiply and divide here, right? So I'm going to take 6.58 times the sine of 57, and I know that's equal to C times the sine of 80. And now, if you want, you can type these in the calculator at this point. It's kind of up to you. I'll do it on this one, then I'll show you the way that I think is easier. But sine of 57 we can find as 0.8387. C times the sine of 80 is 0.9848. And now we can multiply these two together, and we get 5.5186 equals, I'm going to switch this around, 0.9848 times C. Divide both sides by 0.9848. To get C. C then is equal to 5.60. Okay. Now, I mentioned another way. If you want, you could just leave it in terms of sine and here. So you could just divide both sides by sine of 80, cancel those out, and C then equals 6.58 times the sine of 57 divided by the sine of 80. And if you type that all in your calculator, you find you get 5.60. So either way, doesn't matter. You end up with C being 5.60. All right, so now we have to find so we have C, we have to find angle B and side B. If you jump right to the law of sines here, you're going to be setting yourself up for a little trouble, because we do know A, 6.58, and we know the angle for A, so 80, sine of 80. But if we try to set up B over sine of B here, we still don't know either one. Two variables, we're not going to be able to use this proportion to solve it. But if you stop a minute and you go, hey, wait, this is a geometry problem, right? You've got two angles of your triangle, you need the third. How can we find angle B? Hopefully you're thinking, well, angle B is just going to be 180 degrees, because there's 180 degrees in a triangle. And then I can subtract A and subtract C, and that will give me angle B. And you are correct. That'll work just fine. That gives us 43 degrees. And so we see angle B is 43 degrees. So now I can come down here and use the law of sines. Sine. I can cross multiply here. I get 6.58 times the sine of 43 equals B times the sine of 80. Divide both sides by sine of 80. I get 6.58 sine 43 divided by the sine of 80. And when I do that, I'm going to get 4.56 for side B. Okay. So let's just do a quick summary. Law of sines, we have the opposite side divided by sine of the opposite angle is always going to be equal. So B over sine B equals C over sine of C. And so to solve this triangle, to find all of the sides and all of the angles, we're going to set up Law of sines, we had to find the pair that we have, sine of A over A, or A over sine A, equals, and then we did little c over sine of C. We solved this by cross multiplying and dividing. That gave us C. To find angle B, we had to take 180 degrees in the triangle, subtract 80 and 57 to find the 43. Once we had the 43, we could set up another law of sines here. We've got A over sine of A equals B over sine of B. Cross multiply, divide to get 4.56 for B. And that is how you do the law of sines.